Okay, now let's move on to the force distribution of the block here. Okay, so force distribution, we will relate it to with the second Newton's law. Okay, so this is force distribution. Okay, force distribution, as you can see, we have the F buoyant, which is buoyant force, will be minus with the wave, okay, and equal to ma. So F buoyant minus wave is equal to ma. Okay, and m is the mass of the block. Okay, and then we break to the w, which is F buoyant minus mba, mb multiply with g, because this is the wave, multiply with g is equal to mb multiply with a. Okay, so a is the acceleration, which is directed upward. Okay, directed upward. Okay, now we break through again. F buoyant is minus with mb times g equal to mb times y double dot. So this one is what we want to find. Okay, the acceleration of the system. Okay, now we are going to break through the mb and then the F buoyant. Okay, now F buoyant, we know that it is equal to rho FGV. So rho F times G times V minus with MB, which is equal to rho B times A times H. So rho B times A times H. Okay, so equal to MB times Y double dot. Okay, now here, as you can see, we have the F buoyant. I would like to make an correction here. Alright, I say that F buoyant is equal to rho F times G times V, right? So we know that rho F is the density of fluid, and G is the gravitational acceleration, and V is actually volume of submerged fluid by the block. So what is volume of submerged fluid by the block? Is actually here. Okay, this is this amount here. Let me get the point. This right here is how much volume of fluid that been submerged by the fluid. Okay, now as you can see, we don't know how much volume that has been submerged by the block, right? So here we will break through the volume as the length times length times length, right? Okay, now length is what we call as the length times length is represented as the A, which is the cross-sectional area, right? Cross-sectional area. And another length is represented as the height. Okay, the height, which is the height of this point, from the surface of the water, from here, surface of the fluid, sorry, until here. What is the height from here until here? So this will be represented as the, I'll write it here as the y modulus. Okay, this is from here to here is y modulus. Okay, so this is equal to y modulus. Okay, now as you can see, this y modulus, okay, we will present it as the negative. Okay, why? Because it will be measured from the y equal to 0 until here, which is downward. Okay, downward. So that means y double dot will be equal to negative. Okay, so here I'll break to, so rho F times G times A times modulus Y. Okay, what modulus Y is actually negative. Okay, and then minus rho B times A times H equal to MB times Y double dot. Okay, so here this equation will become negative due to this. Okay, so it will become negative rho F times G times A times modulus Y. Okay, minus with rho B times A times H equal to MB times Y double dot. And MB will break through again as this one. Okay, rho B times A times H. So this minus times G, this is times G. Okay, here. Okay, and then again break through again, rho F times G times A times Y. Okay, minus rho B times A times H times G equal to MB times Y double dot. Okay, so sorry, whatever. Okay, so rho minus rho F times G times A times Y over MB minus rho B times A times H times G over MB equal to Y double dot. Okay, now I broke through again, so negative rho F times Y, times what the hell? Times G, sorry, times G. Times G times A times Y over, which is represent as MB, represent as MB times A times H minus rho B times A times H times G over rho B times A times H equal to Y double dot. And from here we can cancel out this one. Okay, and this one also. A. Okay, now we will get here. Okay, Y double dot is equal to negative rho F times G times Y over rho B times H minus G. This is how we get the acceleration of the Y double dot. Okay, the acceleration of the system. Okay, now I'll move on to another equation, that is how do we determine the Y equilibrium. Okay, so where is Y equilibrium? This one. How do we determine Y equilibrium? Okay, this is our main problem here. How do we determine Y equilibrium? We know that the acceleration Y double dot. Now how do we calculate Y equilibrium? Where is the equilibrium position? Okay, from here I will tell you that Y equilibrium is not equal to 0. Okay, Y equilibrium is not equal to 0. This is not Y equilibrium. Okay, so to determine Y equilibrium, always remember that the acceleration at the Y equilibrium position, which is Y double dot equilibrium, is equal to 0. Okay, so to get Y equilibrium, we will relate to this equation, Y double dot of the equilibrium, Y acceleration of the equilibrium. So here this will become Y double dot equilibrium equal to 0, right? So Y double dot equilibrium is equal to, same as it is still same. You have to copy back this equation, but the Y will becomes Y equilibrium. Okay, so rho F times G times Y equilibrium over rho B times H minus G. So here is the most confusing and the most long taking time I have ever done. Okay, so this G, okay, as you can see in the what's that called? I forgot. What is that called? I forgot. Hold on. Okay. So here we know that this will be equal to 0. Alright, so negative rho f times g times y equilibrium, okay, over rho b times h minus g is equal to 0. Alright, now y equilibrium, okay, hold on, damn, I forgot. Okay, we move on. We will move g to the right side. So what we get? Minus rho f times g times y equilibriums over rho b times h minus g is equal to 0, right? So here we'll move g to the right side, so we will get negative rho f times g times y equilibriums over rho b times h equal to g, right? So we move y equilibrium on the how do we call that? Divorce this, okay, divorce. So rho f times g over rho b times h multiply with y equilibrium over 1 is equal to g. So here you can actually move this to the right side and let y equilibrium as a subject. So y equilibrium is equal to g times with the rho b times h over rho f times g, right? So here we can cancel out g, okay, so we will get y equilibrium is equal to rho b times h over rho f, and here we can do some factorization. So rho b over rho f times h, okay, right? Oh, sorry, the minus sign, right? The minus sign here. This is okay. So y equilibrium equal to negative rho b over rho f times h. Okay. Now here comes the another concept. So here y equilibrium we have the three condition. Okay, the first one and the third one. Okay, the first one, second one, and third one. So the first one, the first condition is if rho b is equal to rho f. Okay, what happens if the density of the block is equal to the density of fluid? Okay, so what happens here if we calculate y equilibrium, which is rho b equal to rho f? So what happens is we will get y equilibrium is equal to negative h. Okay, so negative h means that, okay, this is the position, the coordinate. Okay, as I said, this is y equal to 0, right? So y equal to 0 is the surface of the fluid. Okay, so where is y equilibrium equal to negative h? Right here. This is the block. Oh dear, sorry. This is the block. So that block, okay, the top of the block is on the surface. On the surface. Okay, this top of the block is on the surface. This is not fully submerged in the fluid. It only says that it only submerged the top of the block is stay on the surface of the fluid. This is not fully submerged. Okay, this is what we call the top of the block. Okay, I will write the conclusion. Okay, the conclusion. Okay, the conclusion is that top of the block still visible. We can still see the top of the block. This is not fully submerged. Okay, which is means that the block, okay, the block which is except the top is fully submerged in the fluid, but the top of the block is still not submerged. Okay, that means that it is not fully submerged. Okay, that is the first condition. Okay, now what if rho b, which is the density of the block, more than the density of the fluid. So what does density mean? Density, as I said, density is mass over volume. So if density is more, which is plus, right, more, that means that mass is more, okay, and then volume less. Alright, so that means that if the density of the block is more, okay, the density of the block is more than the block and the fluid, that means that this object is heavy, which is means that it will be fully submerged. Fully submerged in the fluid. Because why? Because the density of the fluid, the density of the block is more than the density of the fluid. Okay, rho b is more than rho f. We will get that the block is fully submerged in the fluid. Why? Because it is heavy, more mass. Okay, that's what it means. So y equilibrium, we know that y equilibrium will less than zero, and at the same time the conclusion will becomes block is fully submerged in the fluid. Okay, now the third condition is, what if the density of the block is less than the density of fluid. Okay, so here we will calculate that. Okay, we will calculate that y equilibrium is more than how do you say this? Less than. Sorry. So if the block is less dense density than the density of the fluid, that means that, okay, density less, that means that the block is light. Light means that the block will not fully submerge. When it is not fully submerged, that means this block is floating, or we call that it is partially submerged. Okay, so this is how the conclusion. Okay, this is the conclusion. Okay, so from here is what comes to the a new equation. Okay, so y double dot. Okay, now we go back to the acceleration of this system if the density of the block is less than the density of fluid. So we know that the acceleration is y double dot is equal to negative rho f times g times y over rho b times h minus with g. Okay, here is the most confusing part. Okay, so I want you guys to factorize. Okay, I want you guys to let this y put aside. Okay, so y double dot is equal to negative rho f times g over rho b times h multiply with y minus this g. Okay, so this g, if you read the lecture notes, this g will disappear. Okay, so this g is come from here. Okay, it come from the the acceleration of y equilibrium, which is equal to 0, right? Okay, so y equilibrium, the y double dot equilibrium is equal to uh, negative, negative rho b times not rho b, rho f times g times y equilibrium over rho b times h minus g is equal to 0, right? So this g will move on to the right side, which is g equal to negative rho f times g times y equilibrium over rho b times h. So this is how we get the g. Okay, although that the g, there is a g in this equation, but don't worry, just substitute this g in this equation. Okay, so y double dot is equal to negative rho b times g over rho rho f times rho f times g over rho b times h times y minus with this one. Okay, minus rho f times g times y equilibrium over rho b times h. Okay, now we will get here that y double dot is equal to negative rho f times g, okay, over rho b times h, okay, multiply with y plus rho b times g times y equilibrium over rho b times h. Now I want you guys to put aside y equilibrium outside of this equation, so we will get negative rho f times g over rho b times h multiply with y plus rho f times g over rho b times h multiply with y equilibrium. Okay, this is equal to y double dot, right? Alright, here we will get that y equilibriums, y double dot is equal to, factorize this equation, this one and this one. So we will get that negative rho f times g over rho b times h, okay, times is y plus y equilibrium. Okay, so not plus, minus. This is minus. Why minus? Because negative multiplied with negative, we will get plus here, right here. Okay, this is how we get the equation of a y double dot. Okay, so that is all, guys. I hope you understand what I teach today. Sorry if it's still some misunderstanding. If there's any misunderstanding, you can contact me back, and thank you and have a nice day.